We're going to start this video by showing one more example of the tangent function with respect to our sum and difference formulas. And we're going to use the special angle again. So we have this tan of negative 7 pi twelfths. Now, one thing that we can do with this is we can start and remember that the tangent function is odd. And since tangent is odd, what that means is that the tangent of the opposite of x is equal to the opposite of the tangent of x. And so this could be say that this is really the same thing as the opposite of the tangent of 7 pi twelfths. So that way we don't have to worry about like the negative angle inside of here. Okay. And just to remind yourself that sine is also odd and cosine is even. Okay. So if you were to see something like this before, you would want to use the even and odd principles. In an earlier video, we broke up 7 pi twelfths into 4 pi twelfths plus 3 pi twelfths. And the reason we did that was because we could simplify that to pi thirds plus pi fourths. And so now we can write this as the opposite of the tangent of pi thirds plus pi fourths. All right. And then at this point, what we could do is we could look into our formula sheet and we can find tangent of x plus y, right? Since it follows that pattern. And so our tangent of x plus y is would be tan x plus tan y divided by 1 minus tan x tan y. All right, so let's go ahead and write this. And so this is now going to be the opposite of that statement. Okay, so let me erase this because we really don't need it. So that's going to be tan x, so that's tan of pi thirds minus tan y, which is tan of pi fourths. And then that's going to be, let me just check this just to make sure, 1 plus. Okay, so we have tan x, I'm sorry, tan x. So it should be tan x plus tan y since we're doing x plus y, and then 1 minus tan x tan y. Okay, so, and 1 minus tan of pi thirds, tan of pi fourths. All right. And remember, it's the opposite of all that. So now we just need to evaluate what tan of pi thirds and tan of pi fourths is. Well, tan of pi thirds, remember the tangent in the unit circle is y divided by x, and the y coordinate is going to be root 3 over 2. The x coordinate is going to be 1/2. This becomes root 3 over 2 times 2 over 1 by multiplying by the reciprocal, or that's the square root of 3. Tangent of pi fourths at y over x is going to be root 2 over 2 divided by root 2 over 2, which is 1. Okay, so these are the values that we're going to substitute back in right here. And so this is going to now be the opposite of the tangent of pi thirds, which was root 3, plus 1, which was the tangent of pi fourths, and then 1 minus tan of pi thirds is root 3, and then tan of pi fourths is 1. Right? And you might remember in the previous video that we do have to rationalize this. And to rationalize it, what we're going to do is we're going to multiply by the conjugate. Okay, so the conjugate is going to be 1 plus root 3. Okay, so we're going to multiply the numerator and denominator by the conjugate. And clearly, this is going to go away, this times 1. All right, so that's just doesn't even matter because we're multiplying by 1. Right? Remember, we're going to FOIL everything. Don't forget about that negative sign that is all the way out front. And so that's going to be now the opposite of root 3 times 1, root 3. Okay? And then root 3 times root 3 is 3. 1 times 1 is 1. And then 1 times root 3 is going to be another root 3. Okay? All right. And so in the denominator, okay, that's going to be 1 times 1 is 1. 1 times root 3 is root 3. Root 3 times, or negative root 3 times 1 is negative roots of 3. Negative root 3 times root 3 is just going to be a negative 3. And so now this is going to equal, if we simplify, those cancel, the denominator should be negative 2. So we have an opposite out here. 3 plus 1 is 4. And then root 3 plus root 3 is 2 roots of 3. Right? Now, finally, to finish this off, negative and negative is positive. And so this is going to be equal to 4 over 2 plus 2 roots of 3 over 2, or 2 plus the square root of 3. Okay, so that should be our answer for this. And of course, we want to check this in our calculators. Okay, so let's type in our tangent of negative 7 pi over 12. Right? Make sure we're in radian mode. We get this 3.732, whatever it might be. Okay, and that's fine. But now let's go ahead and figure out what 2 plus the square root of 3 is. Right? And it just so happens that it's that precise approximation. Okay, so at least we know that at least we know we've gotten it right by going through and doing this. Okay, now another set of examples is where we're given two of the values. Okay, and we're given two values of a trigonometric function, and we're asked to be able to figure out some other stuff about the angles. So sine of a plus b, cos of a plus b. All right, so and it's also to rationalize what's necessary. So sine of A is 3/5, and A is in quadrant 2, and B is negative 5/13, and B is in quadrant 3. All right, so the first thing we need to do is we need to build some right triangles for these. Okay, so let's call this angle A, and let's call this angle B. And remember that the sine is the opposite over the hypotenuse. Okay, so this is going to be 3 and 5. And then we could just use our Pythagorean theorem and just do c squared equals a squared plus b squared. Okay, so I'll just write this out really quickly. It should be 5 squared, not 25, even though it is 25. So 5 squared equals 3 squared plus b squared. 25 equals 9 plus b squared. All right, subtracting 9 from both sides, 16 equals b squared, so 4 equals b. Right? And then we can do the same thing with the other triangle. Now, ignore the negative sign because we're going to figure that out in a few moments, okay? So, and remember, this is in quadrant 2. This one's in quadrant 3. And so we know that sine is the opposite over the hypotenuse, okay? And so if we evaluate this, okay, we're going to have 13 squared equals 5 squared plus b squared. 13 squared is 169. 5 squared is 25. We subtract 25 from both sides. We get 144 equals b squared, and then 12 is equal to b. All right, so now we could go ahead and figure out what the sine of a plus b is by using the sum and difference formula. Okay, now remember, the sine of a plus b, sine cos plus cos sine. Okay, so this is going to be, for I, that's going to be the sine of A, the cos of B, and then plus the cos of A, and then the sine of B. Now, we certainly know what sine of B and sine of A are. Okay, so this is going to be equal to 3/5, and this is going to be down here, or sine of B is going to be a negative 5/13. Okay, the cosine of A. Now, in quadrant 2, remember we had our all students take calculus. And so in quadrant 2, only the sine function is positive, and in quadrant 3, only the tangent function is positive. And so what that means is in quadrant 2, okay, we know that the cos is negative, so the cos of A is negative, and then in quadrant 3, the cos of B is also negative. All right, and so now what we can do is we can just substitute those values back in. Okay, so the cosine of B, remember cosine is adjacent over hypotenuse. And so over here for A, that's going to be negative 4/5, all right, adjacent over hypotenuse, right? And then the cosine of B. If we look back at this, we have to make sure it's B. So it's going to be 12/13. Okay, so the adjacent over the hypotenuse, and it's negative. That'll be negative 12/13. And then the cosine of A is negative 4/5. Okay, and again, that's because it's negative because it falls in quadrant 3, and the cosine is only positive in quadrants 1 and 4. Right. So now we finish this off by multiplying. 3 times negative 12 is negative 36. 5 times 13 is going to give us 65. And then negative 4 times negative 5 is 20. Right? And then finally, we just add those together. So negative 36 and 20 are going to work out to be negative 16/65. Okay? Now, if I want to figure out the cosine of a plus b, once again, I just use our formula. Okay, so we look at our formula. We have cos of xy is cos minus sine sine. Okay, so if we were to look at the cos of a plus b, sorry, trying to make that look like a real cosine. Didn't do a good job there. All right. So that's going to be our cos minus sine sine. Okay. So looking again at our formulas, cos minus sine sine. Right. So that's going to be our cos A, cos B minus sine A, sine B. Right. And remember, cos of A and cos of B are both negative, but we already have all those, right? We could just substitute back in from this, okay? So cosine of A is going to be negative 4/5. Cosine of B is going to be negative 12/13. Sine of A is 3/5. Sine of B is negative 5/13. And so when we multiply this out, negative 4 times 12 is going to give us a 48. We know the denominator is 65. And then 3 times negative 5 is negative 15, but we have a minus there. That just turns into 15. And then 48 plus 15 should give us our 63/65. Finally, we want to figure out what the tangent of a plus b is. Okay, so this should be a capital A. All right, so we go into our formula sheet, and we have tangent of x plus y is tan x plus tan y, 1 minus tan xy. Okay, so that's going to be tan of A plus tan of B divided by 1 minus tan A tan B, right? And so remember, we go back up to our all students take calculus, and the only time that the tangent function is positive is in quadrant 3, okay? And so what that means is that B, the tan of B, is greater than 0, right? But the tan of A is less than 0, right? So whatever we get for the tangent function for this triangle, all right, and remember tangent is opposite over adjacent, so that's going to be 3/4, but it'll be a negative, okay? So tan of A is negative 3/4, okay? Remember A is in quadrant 2, and then over here, opposite over adjacent is going to be 5/12 positive, okay? So tan of B is going to be 5/12. So we just substitute those values in, okay? So we know the tangent of A, negative 3/4, and then 5/12. And then in the denominator, that's going to be 1 minus a negative 3/4 times 5/12. All right. So this is going to be a little bit ugly, but no worries. We can clear this up in a few moments. So in the denominator, this is just going to turn into 1 plus 15/48. All right. And I want you to notice that both of these are negative. So it turns into a positive, and we just multiply across. And then the numerator, that's just going to be negative 3/4 plus 5/12. Now, what I'm going to do is I'm going to multiply everything by 48/48. All right. It's just because that's going to clear everything out. All right. So if I multiply, so let me change colors here just to show you how to simplify this really nicely. And of course, we could add these fractions and multiply by the reciprocal as well. In fact, that seems like a little easier way to do it. So we just get a common denominator of, in this case, the common denominator will be 12. All right, so let's just multiply by 3/3 to get to 12. So this will be negative 9/12. Okay. So We get negative 9/12 plus 5/12. And then the denominator, we can write 1 is 48 over 48 plus 15 over 48. And so the numerator is going to become negative 4/12. And then 48 and 15 is going to be 63 over 48. And then now we can multiply by the reciprocal. Okay, so we get negative 4/12 times 48 over 63, right? 12 times 4 is 48. So this just turns into 4 and 1. And so this should work out to be negative 16/63. All right. Now, I don't know if there's a nice way for us to be able to figure that out by using our calculator. Okay. So unfortunately, we're kind of saddled with that. We could certainly plug in this expression into our calculator. All right. And that should give us the negative 16 over 63. Okay. All right, so when you're doing these problems, and we'll do another one of these in the next video, keep in mind that the quadrants are going to determine what the signs, SIGNS, are going to be of these trigonometric functions. Okay, so keep that in mind. And then also we just draw our right triangles to be able to figure out those. And then finally, we just go through and use our sum and difference formulas to be able to evaluate.